Hello guys, this is codeNcode and this is a problem micro and prime taken from Hacker Earth. So let me make it a little big. Yeah. So the problem is there's a person micro who has defined a new type of number called prime and a number is called prime if a number x is called a prime if number of prime from 1 to x, the total number of prime from 1 to x are also prime, then the number x would be called prime. So number 3 would be prime because total number of prime till 1 to 3 are 2, and since 2 is also a prime, that is why number 3 would be prime. So what we have to do is we are given t test cases, and in each test case we are given L and R, and we have to tell how many prime numbers are in between L and R. So to solve this, we would of course since L and R are up to 10 to the power 6 and there are 10 to the power 5 queries, so of course we would use sieve to generate all the prime numbers till 10 to the power 6, and then we would use cumulative sum array to find the sum of number of prime from 1 to x in constant time. So if you do not know what these are, just bear with me and let's start. Okay, so here we go. So we take an integer array of size 10 to the power 6 because in the input L and R can be as large as 10 to the power 6, and then we have our void sieve array. So in max n is equals to 1,000,000 10 to the power 6, that is, and we would make all the numbers from 1 to max n as 1, indicating that they all are prime number. But since we know 0 and 1 are not prime numbers, so we would mark them 0, and now we would start our sieve. So LLI is long int as I have defined. So LLI is I is equals to 2, and we run a loop till square root of n, that is why we are running a loop till square root of max n, and I plus plus if AR of I is equals to 1, or simply you can leave it as it is, so it would not change anything. So if AR of I is double equal to 1, which indicate it is a prime number, then what we would do, we would go to all the multiples of it and we would start j is equals to I into I. We would start from I square and then j is less than equals to max n, j plus equals to I. We would start from I square, and then for all multiple of I we would mark them as composite number, and hence we would mark them as 0. Now after running through this, now the array AR contains information about prime number. So ith index of array is 1 if the number is prime, if the number I is prime, otherwise it is 0. Now let's use a count variable and then run a loop till max n. Now if AR of I is equals to 1, indicating that this is a prime number, then our count would increment. If the ith number is prime number, then we would increment the count, that is count is basically number of prime number from 1 to I. So if ith number is prime number, then we have to increment it. So now count contains number of prime number from 1 to index I. So we should also have an array for prime numbers, or was it? Yes, for prime numbers. Its size would also be 10 to the power 6. So now ith index of pp or ith number would be prime if the number of prime from 1 to I, which is this, is also a prime. So if AR of count is equals to 1, so what it means that the number of prime number from 1 to I are prime. So if that's the case, then pp of I would be 1, indicating yes, this is also a prime number, else pp of I would be 0, since this is not a prime number. So after this, pp of I contains 1 if the ith number is prime and pp of I contains 0 if the ith number is not a prime number. So from the main function we can directly call save, and everything is ready. We just have to take these test cases and in L, R and T. So in each test case, we would read L, R, and for now I'm just to show you, we would initialize count with 0 and we would run a loop while R and I plus L plus plus, and simply count plus equals pp of L. So if L would move from L to R, of course. So if L is pp, then it would be 1 and hence count would be incremented. If it is not, then pp of L would be 0, so count would not be incremented, and we can direct print it. So let's compile it here. Okay, C++14. We may get some compilation error, but that's okay. Yeah, I was NPRE. Oh, sorry, 39.6. Here, it's actually REP. So now it should work. Okay, the sample test cases are passing, but if you submit it, we are likely to get TLE. The reason is because there may be partially accepted, only 6 marks, because the rest are TLE. The reason is because there are 10 to the power 5 test cases, and in each test cases L and R can be as large as 10 to the power 6. So the overall complexity would be T into N, where N is 10 to the power 6. So the worst case we have to make 10 to the power 15 calculations. So it would result into TLE. So what we can do is, let me copy this, which one is correct one. So now we can do is, we can take a cumulative sum of pp. So what we are going to do, we know that ppi is equals to 1, right? If ith number is prime. Now what we are going to do, at ith position, instead of saving whether it's a prime number or not, we are going to save the total number of prime number from 1 to I. Or basically, if you have no idea, then you can check, this is called cumulative sum. So we are going to prepare the cumulative sum array of pp. So now at position 1, there will be sum of first only one pp number. At position at position 5 we have the sum of all pp number from 1 to 5. So at position 5 it is not, now it is not whether the fifth number is prime number or not. At position 5 there is total sum from 1 to 5, how many prime numbers are there. So now it contains sum. So to now the answer can be given in constant time like this. All you gotta do is take how many elements are there till r and subtract how many elements are there till n-1, and this is your answer. Let me take, let's just compile it again and submit it. So we got 20 numbers, because now for each test case we are calculating the total sum in constant time. So what it is actually, if you have no idea about the cumulative sum so what it does is actually, if you want to find the total number of element, or suppose you have an array and if you want to find the total sum from L to R, instead of saving the array in the array is at ith position, instead of saving ith element, like ith element is 4 or 5, instead we can save the sum till I. So if the array was 1 2 3 initially, so at position 1 we would have 1, at position 2 we would have 4 because the sum of first two number, at position 3 we would have 6. So if you want to find sum from L to R, all you can do, take total sum from 1 to R, that is AR of R directly, which is this, and then subtract 1 to L-1, and this is how we are calculating. If you are having any problem, just use your pen and paper and you'd know what this thing is. So this was the problem taken from HackerEarth, that was micro and prime, in which we have implemented sieve along with the cumulative sum array. So thank you guys for watching, and keep coding. Thank you.